Hello dear student, today in this video we are going to discuss an important topic, that is about when a function f so we have a function f, then when we tell that it belongs to LPR, or suppose when we say that f belongs to, it can also written as lower p, upper p or lower p, LP 0 infinity, or f belongs to LP minus infinity 0, or f belongs to LP 0,1, right? These are when does it say this, when you can tell this happen. Okay, so I am writing some division first. So we have a function fx, your mod x is belongs to. The question is, for this function, can you say f belongs to L2 minus infinity? Can you say this function belongs to L2 minus infinity? Recall. First we have to recall a definition. Right? This is the definition. If f belongs to LP for any prime p, LP whatever I was set minus infinity, right? F belongs to LP minus infinity, if and only entirely minus infinity, so minus infinity to infinity, mod fx equal to p dx, this should be finite. It's finite. Minus infinity to infinity, fx whole to p dx, this will be finite. If this happen, then we can say that f belongs to LP minus infinity, right? So if there is 2 in place of 2, if suppose p is 2, then we have to take p is 2, right? So this become minus infinity mod fx power 2 dx, this will be finite. Okay, so this will be minus infinity mod fx to p dx will be finite. Minus infinity fx to 2 dx will be finite in this case. Okay, so we have to check this whether it is happen or not. If this happen, then we can tell that this function, the function belongs to L2 minus infinity, right? So I have to check the integral minus infinity mod fx to dx, right? This means minus infinity. This e to x function is always positive. We all know that e to x always get a 0, right? So e to mod x always get a 0. So if we have to take square of this function, square, then it is also positive, right? So if you take mod of this function e to x, this is also positive. It's a positive function, so never no need to take its mod. It mod in itself. For a positive function, if x is greater 0, always happen mod x equal to x, right? Since e to r minus mod x is greater 0, so e to r minus e to r mod x will be mod of this would be this itself, and outside is square. So this become minus infinity e to r 2 mod x, right? We get this minus infinity e to r 2 mod x dx, right? Now we have to break out this two integral. This integral we have to break into two integral. minus infinity mod which are 2 mod x dx, which break is minus infinity 0 2. Here something happen. What happened? I am writing this 2 mod. Here something happen. See, mod x equals, we know all know that this definition. Mod x equal to x if x greater 0, right? And minus x if x less than 0. So if x ranges from this set, x lies between minus infinity less x less 0. So mod x means minus x, so here minus x appear, right? Or if x lies this set, lies this interval, so 0 less than x less than infinity, so this implies mod x equal to x greater 0, so mod x implies x, so in this place we have to write x, right? So we get minus infinity 0 2x dx, we get 0 to infinity 2x. If we integrate this, it will minus 2x by 2 minus infinity 0, and this become it will minus 2x 0 to infinity. So this becomes it is 0 half, it will minus infinity 0, it is 0 is minus 2, so this becomes 0 half, it is infinity 0. If you put in extend to infinity, then this becomes 0, this goes to 0, right? So half plus half, so we get half plus half, half plus half means 1, right? So we get a value is 1. So if we calculate this minus infinity fx dx, this value is become 1, and if find quantity, this can be made less than infinity, right? So for the function f is equal to e to power 2 mod x belongs to r, we get this integral minus infinity mod fx 2 power 2 dx, this is 1, and this is finite quantity, right? So you can tell from here, if only condition, then f belongs to what is power p, so L2, and interval is minus infinity, so L2 minus infinity, right? So this function belongs to L2 minus infinity. Similarly, you can tell that if f is a zero function, x belongs to r, then this function, for this function check this is belongs to L2 0, 1, right? How we check? So we have to, for L2 0, 1, here is p, so we have to integrate, and the interval is 0 1, so 0 to 1, right? Lower and upper end, and it will be mod x power p, so p here is 2, so 2, but 0 to 1 mod fx the square dx, if it is 0, the mod is 0, so 0 to 1 integral itself 0, so this becomes 0, okay? So this integral becomes 0, and 0 is a always finite quantity, so we can easily tell this 0 function, we can easily tell that the 0 function, this f belongs to L2 0, 1. Similarly, if we take f is equal to 1 constant function belongs to R, whether if to check, if we want to check whether this function belongs to f Lebesgue integral or L2 minus 1, L2 minus 1, then how we will proceed? We have to proceed for this integral. We want to check f is equal to 1 x belongs to minus 1. Okay, I have to check whether this function belongs to L2 minus 1. So for this we have to calculate this integral. Minus 1 integral is minus 1 and mod fx is to L2, so power is 2 dx. So minus 1 to 1, mod fx is 1 dx. Lower into upper end integral is 2, and 2 is a finite quantity, right? 2 is a finite quantity, so this integral become finite. As this integral become finite, minus 1 to 1 mod fx power p means 2 dx is finite integral. It's a finite integral. So we can easily tell that this function, the function f belongs to L2 minus 1, right? This is what the LP function. In general, we can tell this as a note. Writing a note. In general, we can tell this a function f belongs to LP for any interval, whatever may be AB, LP AB, or f belongs to LP a set E, where E is a measure of the set. E subset are in real number. If and only integral, if it LP AB, then it integral would be a to b. Mod fx, here is p, so p dx, this will be finite. And for this set, if it is LP AP, then integral over E, it's level integral mod x f power p ds, this would be finite. Okay, if it is the set if f belongs to LP E, f belongs to LP, if only integral over E mod fs power p ds, this will be finite, right? Mod f power p will be finite. So we have learned this concept. A function f belongs to LP AB, where AB are finite, or maybe both infinity. One is infinity, one minus infinity, another is infinity. This can be also happen. Then this equivalent definition, if the integral is finite, minus infinity, so the integral is finite. It to be mod fx power p, this integral should be finite, right? Similarly, if f belongs to LP E, and for any set E subset R, if only integral over E mod fx power p ds, this would be finite. This would happen. If this is integral finite, then we can tell that f belongs to LP E, or if this integral is finite, then we can tell that f belongs to LP open AB. Okay, LP a belongs to LP AB, if only AB A to be mod f star p ds is finite. If and a belongs to LP E, for her E is any subset of R, if the integral over E is level integral mod f star p ds is finite. And using this concept, we can easily tell that for a function f belongs to LP R, R means minus infinity open interval, right? F belongs to LP R, F belongs to LP R, or F belongs to LP minus infinity, because R means minus infinity open interval. If I only in this integral minus infinity mod fx, here is p, so upper power is p, this is finite. Okay, and I have checked the function. What is the function? F is equal to e to the minus 2 mod x. This function h belongs to R. Okay, I have checked this function. This function belongs to LP. This function belongs to L2 minus infinity. In a video previously, I have checked this function belongs to L2 minus infinity using this definition. is in this function. Minus infinity mod of s dot pds is finite for this function, so this function must be equal to minus infinity, right? Okay, so thank you.